Yeah, good evening, everyone. I'm waiting for the speaker to join. So we'll start at 4 p.m. once he joins. Let me try to call him up. Anand, you join?
Hello.
Yeah, you can hear me?
Yeah, I can hear you.
Yeah, okay.
Just
We'll wait for 2-3 minutes and then we'll start.
yeah, just let me test the presentation.
Yeah.
Yeah. Share screen or share files?
Share screen.
I need to log off and log in again, Harish.
You have to log in again.
Yeah.
Okay, fine. Yeah, Anand, you are able to do it?
Yeah. Now I can see the presentation.
Yeah, it's coming now.
Yeah.
Yeah, so I think the time is up. So let
So
me start
we should
first.
start. I think we should start. Yeah. Nitish, phone get
Okay, so good evening, everyone. So we'll start. So welcome to the webinar. So this is part of webinar series 1, which we are organizing, which AAR is organizing. And today we are conducting topic 4, which is harmful effects of water, dirt, and oil in an ammonia refrigeration system. Okay. So Mr. Anand Joshi from Manik Engineers Pune, he will be the expert speaker today on this subject. So welcome, Mr. Anand.
Yeah. Thank you, Harish.
So a little introduction about Mr. Anand. Many of you know him already. So Mr. Anand, he is director at Manik Engineers India. He's an engineer from Bharati Vidyapeeth College of Engineering in Industrial Electronics and Instrumentation. Yeah, he's synonymous with Manik, which is a well-known brand for refrigeration controls. And he's pioneer in many cost-effective refrigeration plant control solutions. He has a vast experience of 35 years, have generated different products and solutions for energy optimization and conservation. He is also past president of Association of Ammonia Refrigeration, past president ASHRAE Pune and chapter. He is also member of ASHRAE, Indo-German Chamber of Commerce, Indian Institute of Electronic and Telecommunication Engineers, Indian Dairy Association, and RATA. So there are some partners who are helping us organize this webinar. So yeah, so we have Manik Engineers. Thank you, Manik Engineers. So then we have Frick India. Frick India has been supporting AR since inception. So thank you, Frick India. Then Darren Brown is a new company which makes chemicals for evaporative condensers and cooling towers. So we thank them for their support as well. Neptune Refrigeration, also a very old company who have been supporting AR all along. So thank you, Neptune Refrigeration. So little about AR. AR is a non-profit organization which is established in the year 2012, and our aim is to promote safe use of ammonia as refrigerant through education, training, information, and standards. So this is the current board of AAR. So it consists of subject matter experts and technocrats. I am the current president for this financial year. Our achievements have been we have 9 corporate members. We have more than 350 individual members. We have trained more than 18,000 delegates. We have done 90 advantage ammonia programs, 45 technical presentations at other forums, 35 webinars, and 9 ARCON, which is our annual event, AR member networking events, and a lot of publications we do. So those are the activities. These are our current corporate members. Some are in renewal process. So this list is going to expand. These are the publications we have. So apart from the newsletter, which we publish every quarter, we publish some books and guides for the benefit of the industry. This is a standard on which we had put a lot of work, and we came out with a standard, safety standard for equipment design installation of closed circuit ammonia mechanical refrigeration system. So based on this, BIS has adopted this, and IS standard is now available. Advantage ammonia programs, these are in-person programs we have been doing, and they are very popular over the last 10-12 years, what we have been doing. So this year we have so far successfully conducted 2 programs, one in Pune and the other one at Sangli. And then we have planned to conduct more such programs at Coimbatore, Nashik, Mangalore, and Disa in the coming days. And then webinars, which are free actually, just to spread knowledge of ammonia refrigeration. So we started in June this year, and it has been continuing. So after series 1, we will plan for series 2, and this will be, the webinars will be an ongoing thing. Apart from webinars, we are also thinking of providing online training to the interested companies or individuals. So if any one of you want to have some kind of training which can be conducted online, so you can approach AR. We'll be glad to assist you on that. So the Pune program we had expert speakers, Mr. Paranjpe and Mr. Anil Gulanikar regarding piping design and plant room layout. These are some of the glimpses of the program. Then on 26 June, which was World Refrigeration Day, we conducted a program at Sangli because we wanted to be at the ground level rather than having a big fancy program wherein there is no technical stuff. So yeah, we wanted to be in the midst of the actual end users. So we had a very interesting topics on regarding cold storage, where ammonia is really beneficial as compared to freon refrigerant. So the cold storage, uh, yeah, it was organized by led by Ammonia Refrigeration, supported by us. We are thankful to the partner about the programs which we had. These were some of the pictures of that program, different topics we had. And coming to webinars, as I told, this is the topic. We already had three topics, webinar one on optimizing corporate design, second one on driving process safety excellence in ammonia refrigerant, and third one on new HFO refrigerants and their impact on environment. So then apart from known program, we are supporting various other events also as a supporting organization. So our team visited China Refrigeration. Then we had International Fishery Tech Expo at Mumbai, and soon we'll be there at the Global Ice Plant and Cold Storage Expo, which has been shifted to Mangalore and is on 30 and 31st August. And then World Food Chain Expo, some of our colleagues will be representing AR over there. That is on September 10th and 11th. So we get normally a presentation slot and a free booth for AR to our activities. This is our presence at International Fishery Tech Expo at Mumbai. Arcon, our flagship event, will be held at January at Hyderabad. We are in process of finalizing the venue, and we will share with you soon. This is our website. Many of you must be familiar with it, ammoniaindia.org. So yeah, we are in process of upgrading that as well. Membership, you can, these are the links. You can go to the website also and become a member of AR. We want more and more people to become members of AR so that we can strengthen the organization. Then future plans, as I told, we want to conduct more advantage ammonia programs in various cities. Technical committee is working on other standards as well. We are working on some publications as well. And then this is something which we want to seriously do it, certified course for operators and technicians. Redesign of website, I already told you. And then creating a library and having own office. So this is an appeal to all the members of AR present, volunteer in various committees, contribute towards technical articles in the newsletter, and visit AR website and social media platforms like LinkedIn, Facebook, and your comments on AR in time to time. Any other suggestions you have, and then increasing membership. So if you have any friends who are interested, please do ask them to join AR. So here I'll take a break and hand over to Anand so that we can move ahead with the presentation. Yeah.
Thank you,
Over to you.
Naresh. And it's good to see that a lot of people are joining the webinar. So we also have the AR Ammonia flyer and the AR membership forms available in chat box. So request all of you to download and you can become AR member and of course use the information about ammonia refrigerant as shared by the AR. Now, as we talk about it is today's presentation, and today's presentation is all about harmful effects of water, oil, and dirt in ammonia refrigeration system. So I'm trying to explain my experiences, what I have faced into this with these things, and then what are the harmful effects of it on the system. So I'm thankful to Association of Ammonia Refrigeration for giving this opportunity to make the presentation. And I hope you may be able to get some benefit out of it. As we know, the ammonia purity required is 99.95% for the refrigeration plants, which called as an anhydrous ammonia. However, we normally don't get that kind of pure ammonia, or our ammonia suppliers normally don't supply such pure ammonia, or there are ways in which these uh, impurities or contaminations enter into our system. So let us try to find more about it. Just to, basically when we talk about this, our ammonia temperature pressure chart, which we all refer for our plant operation system design operations and everything. This is the chart is valid only for the pure ammonia, that is anhydrous ammonia. If our ammonia is not anhydrous, it contains water or other things, this chart does not hold good. So to get this results, like we want to get minus 40 degrees centigrade at the pressure of say minus 0.28 bar gauge pressure, we must have pure ammonia. If water is there or other things are there, then you will not get minus 40 at minus 28 degrees, minus 0.28 bar pressure. So let's try to see what is the contamination. Technically, a good ammonia refrigeration system should have a refrigerant and oil, and that's also the oil should only be in compressor or the parts of the oil separator or oil cooler. It should not go into the system. Anything else in our system is a contamination. What are the normal items we observe as a contamination? One is the water, oil, dirt, rust, sludges, and of course the non-condensable gases. Today we are not going to talk about non-condensable gases, but we'll talk about water, oil, and dirt. And even though these three are different parameters, they do affect each other, and definitely their presence contaminates the other one. One like water definitely contaminates the oil, and water definitely generates more rusting or the sludging into the system. See, typically, let's start with the water. Water has got very high affinity to ammonia, has got very high affinity to water. It means when water comes in contact with ammonia, immediately the water and ammonia, they come together and they form one soluble ammonia water. Because of this solubility, the ammonia changes its taste, and from anhydrous ammonia it becomes hydrous ammonia. As the temperature of the solution or ammonia is reduced, the ability of to absorb ammonia increases. Typically, at 30 degrees centigrade, it can absorb around 30% of water. At 0 degrees centigrade, it can absorb about 46% of water. And at minus 33, it can absorb around 100% of water. So typically, for a freezing plant or a low temperature plant, possibility of water and ammonia mixing is 100%. Now, when ammonia and water mixes together, it actually forms ammonium hydroxide. So, ammonium and hydroxide ions can cause corrosions in our system, And when this water mixes with compressor oil, it also has a chemical reaction that creates nitro compounds, which we also call as sludges. And these sludges definitely clog strainers, filters, and the compressors. Now, what is the effect of water mixing into the ammonia? When there is a pure ammonia, you can get a minus 40-degree temperature at minus 0.3 kg per centimeter square ammonia pressure, or at 0 kg you can get minus 33 degrees ammonia temperature. But when you have a 20% of water in ammonia, remember at below minus 30, you can 100% water can get absorbed into the ammonia. So at 20% of dilution, instead of getting minus 40, you will get only minus 36 degrees centigrade. Or instead of getting minus 33, you will get only minus 29 degrees centigrade. So what it means that I will not get my desired refrigeration capacity at my rated condition. To get that rated desired refrigeration capacity, I need more capacity of the compressor, or I need to operate compressor at lower suction pressure to get same refrigeration effect. So these things totally affects our system. Now, how this water comes into our refrigeration system? Water can come through during the initial construction testing setup, and water can come on continuously running the plant. When the plant is being constructed or the equipments are being manufactured, water remains in system in various ways, such that water can remain in vessels when people are doing the hydro testing. Technically, as per AR standard, you should not be doing hydro testing. You should be doing testing with the dinitrogen. But still, many people use the hydro testing for the pressure vessels and other equipments. So then, if the properly is not drained, then you will find a lot of water remaining in the system because it's difficult to dry out these vessels. And when our constructions of the site, ammonia, as we know, is basically a site fabricated refrigeration plant. Many times our pressure vessel connections or the pipes are kept open, and the condensation which happens on this pipe or during this installation when they are open, the condensation goes inside the pipe. If pipes are not properly cleaned, this condensation remains into the pipe, and then that goes with the ammonia. Also, many times people use the air for the pressure testing. Particularly, they use the ammonia compressor to get the air, and then that air is being used as air pressure. So this air, when enters into ammonia, which is the normal atmospheric air, it also contains the moisture. And this moisture which enters in with the air may remain into the pipes and the vessels, and then that cannot be properly evacuated. And when this plant is being running now, we already have a water content into our plant. And now when plant is running or when plant is being charged with ammonia, many times we do not have the certification for the purity of the ammonia we receive. We receive ammonia with water itself. And instead of having 99.95% pure, it may be 95% pure ammonia. So 5% of balance may be water. And that we don't know. And also, as the water, many times we top up the ammonia with ammonia cylinders. The water is there in the cylinder. And to get the full ammonia out of cylinder, we try to rotate the cylinder by 180 degrees and put all the water inside the ammonia. Then there are heat exchangers like shell and tube heat exchangers, which are used as a chillers or condensers or oil coolers, where there is a possibility of leakage and then water entering into the ammonia system from the coolant side. And when you are draining the oil or when you are charging the oil, then also it is possible that air will enter into system and it may contain the water. And when you are operating the plant below atmospheric pressure, that is below minus 33 degrees centigrade, if there is any inside pressure is vacuum. So if there is any leaks into the wall stems, flexible hoses, or any other joints, when air, instead of ammonia coming out, air enter into the system, and along with the air, we have the water inside. Also, when the the proper evacuation is not done when the service is being done or filters are open for cleaning, and if you don't do the proper evacuation, the air enters into the system, along with it the moisture enters into the system. And sometimes between ammonia, oxygen, water, and sludge creates more water into the system. Another important effect is that when we do not have a purging systems or our purgers are not working. See, when purgers is not working, the air enters into system will remain into the system, and water and the moisture which comes into the air becomes water and mixes with the ammonia. If you see this example showing, even if the purger is working and it is purging air, we can see that definitely there will be a water coming in into the system, and at the end of the year we'll have 50 liters of water typically if the purger is just purging 5 liters of air per minute. So this water, when it comes into the system, it mixes with ammonia. Along with ammonia, it causes a lot of effects. As I told you about, the first effect is the is actually increasing the temperature of ammonia at rated pressure. You don't get the rated temperature at the rated pressure, and then there is corrosion, water, and when there's air, it comes together. There is oxidation inside, and it causes the corrosion into the pipes, into the vessels, and then that rust gets formed. Then it also affects the oil in the refrigeration system, and oil starts forming the organic acids, and then sludge gets formed. And then it definitely, due to the water content into the compressors and the oil failures or the deterioration in the oil quality, the compressor wear and tear, spare part damages increases, and also oil. We need to change oil frequently, so more oil is required and a regular more servicing is required. Then as the sludges get formed into the these lines, or this there are the rust forms are into the refrigeration lines, there are pressure drops, the valves controls get affected, pumps and the evaporators performances also get affected when these sludges goes there or gets accumulated there. And water contamination lowers the system efficiency, and as I told you, we need to have a more refrigeration capacity. So we need more refrigeration capacity means we need more electrical input, so we need more power requirement. Now water will normally accumulate on the low pressure side. There is always this misconception on the people, but the most of the time you will find water accumulating into the evaporator sides, into the pump receivers, or the valves and controls, or in suction accumulators for a DX systems. And if we have a two-stage system, it will more accumulate on the low temperature side than the high temperature side. Why it happens like that is very simple, because there is a pressure difference between ammonia and the water. For 2 degrees centigrade, ammonia pressure is 3.6 kg per centimeter square, whereas the water pressure is only 0.007 kg per centimeter square. So when ammonia evaporates, the ammonia goes out, but the water remains into the system, and it remains at the lower side of the vessel. So at the bottom, mostly you will always find this water. The biggest effect of the water in refrigeration system is affects the bearing life of the compressor. As you can see in this graph, the bearing life, depending on the percentage of water which gets mixed into the oil, the bearing life reduces. And as the bearing life reduces, you can see the photographs here where the compressor bearings are damaged, compressors are broken down, and it also damages the compressor screws. Uh, this is typically when water mixed with oil. You will find here that the uh, sludges getting formed onto the filters choking, and then oil also damaging. So you have to need the frequent replacement of the oil. This is a typical example in a piston compressor, how the big sludge is being formed. You can see in these pictures. This is how the valves and controls get affected. You can see because of the water in ammonia, there is so much rusting is happening inside the valves that valves cannot operate, valves choke, and you need to really open all the valves and controls and replace it. These are some more photos showing how the sludge and the water along with the oil damages the controls. You can see here the water content found into the walls, and then it generates the rust and the dust into the system. There are so many photographs which will show you how these various types of wall gets damaged or gets blocked because of this, how the filters get choked, and this sludge and these things keep on forming inside. This damages your walls. Wall seats get damaged. Your gets corrosions inside. These are the I would like to show how much water come out refrigeration line. Just see opening up the filter cap and the water is coming out of it. In video, you can very easily see the water accumulated in the wall itself. Because the walls are installed on low temperature side, you will find water getting into the. So typically, if we when we talk about the main effect of water in India, lowering temperature. So if you want to get -degree, and instead of that, you have to run the plant, say at because of 10% of water condition, you have to run it at -42, or you have to, you are about huge amount of cost of electricity in a, very easily see it is, we are talking of around 700,000 rupees or close to $10 in a year electricity. That's India. A different electricity will vary, and that will also be your revenue loss. Second part, which is part of this presentation, is oil. Oil is a basic liquid and it is used for the lubrication of the systems. Type of oils typically are vegetable oil, mineral oil, and synthetic oil. In our refrigeration, we use only mineral and the synthetic oil. So oil is used in refrigeration plant, in particularly on compressor, for reducing the friction, the cooling the compressor, sealing the clearances with piston or the between the screws, reducing the levels, dampening of these, and cleaning, washing out debris and gum matter particles, reduce corrosion of by the lack of lubrication, lack of oil in ammonia system is one of major cause of the compressor failure. What happens is here, if there is a liquid feedback and then there is a lack of lubrication, compressor is guaranteed likely to be failed. And it the lack of lubrication, there is no sufficient oil. It means the oil is getting carried over into our system. Our oil separators are not working properly, and is getting thrown out, or there is a more like you see the pistons or the piston rings in compressors, or pistons have more PS, or the reason more is there. And if the oil is not there, going to get damaged, and it is definitely going to reduce the life of the compressor. Also, we have to maintain proper level in the compressor slumps in case compressor separator surfaces. And oil pump failure are also very regular, which is in or the sludges into the system. This you can see a lack of lubrication, how the piston is get matched. There is no oil film formed between the piston and the cylinder, and then that rubbing caused the piston damage. This is damage happened to the screw compressor because again, which is lack of the lubrication. And there is another effect of oil, that sometimes our condensers are not working properly, or we have a air in the condenser, and that temperatures, which increases the oil temperature. So high in that case, oil can break also, and chemically it can break. And if oil breaks, normally oil will generate the components which will be non-condensing gases, and those will be affecting the refrigeration capacity. And compressor is not operating is will not be operating in safe limits as the temperature goes high, and then there will be a lot of creating of carbons and acids through oil breakage, and it will damage the compressors. This is how a compressor, screw compressor, get damaged because of the overheating. You can see the screw is being damaged. You can see the how this getting oil effects are there. This is right from left to right. You can see a good quality oil, heated oil, and very badly heated oil. So when the when the compressor discharge temperature increases, the oil compressor oil coolers does not work properly. Oil temperature increases, and oil heating causes the damage to the compressor. Replace the oil, recharge the oil. Sometimes you have to drain the complete oil and put out the new oil. Now, what happens is that if there is a oil carryover happening, then the oil will go into the heat exchangers like condensers or the evaporators, and it will lose the capacity of that equipment will be lost because oil gets accumulated there. And always remember, oil is heavier than ammonia, so it will always get at the lower side of the vessels or the heat exchangers, and that will also affect your instrument level controllers or your level indication systems, which will give which may generate malfunctions or give incorrect signals. So and then it also leads to continuous oil monitoring and oil top up. When we say oil top up, theoretically whatever oil we put in the system, it must come out from somewhere. But if we are not able to get all oil back and we are able to just add the oil, just topping of the oil, it means we are increasing the oil cost, and at the same time oil is getting accumulated somewhere, some points of the on the evaporator sides, on the low pressure sides, and then that is affecting the performance. And then when this oil carryover becomes more, then we also have to drain the oil frequently. And my experience, sometimes in particular gravity-fed systems, your evaporators get full of oil and you are not able to get the refrigeration capacity. And secondly, when this oil travels with ammonia, as we know, oil is not miscible with ammonia. It travels with ammonia, and it may mixes with the water in ammonia, and then it forms a gums, and it definitely gets choked into the system's filters, and it damages the system. As we know, the compressor oil mainly get thrown through the discharge side of the compressor. So it goes to oil separator and then to the condensers, high pressure receivers, intercoolers, low pump receivers, the float liquid columns, strainers, gauges. You can see here, this is a typical photo of a gravity feed cold storage where oil is getting fully accumulated into the float chamber, and the oil is not going inside the evaporator, but just into the accumulator side. So when this system was open and oil was drained, you can see how much oil was accumulated into that standpipe of ammonia and the coil itself. So huge oil needs to be drained out. This oil, along with the dirt and things, get accumulated into your controls filters, and it damages them. Its performance get affected, and when it get choked into the solenoid valves, it definitely leads to the burning of the solenoid coils. Another major effect of this lubrication failure is the bearing life of the compressor. As I told you, when water is there, because of the water, the bearing life reduces. Similarly, failure of the lubricating or quality of the lubricating oil, then start bearings getting damaged, and it gets damaged frequent, and we need to replace the bearings lesser than its operating hours required. So these are some of the photos showing the failures into the bearings. like a surface fatigue on the bearing side, or the progressive surface fatigues. You can see here how it has been damaged. And there is also possibility that many times people mix different oils into different grades of oils, or sometimes people sell us the magical additives, which they claim that they will improve the life of the oil or the life of the performance of the system, which does not happen like that. And these are compatible with the oils you are using or you are there, then wearing or damaging the your compressors, you can very see easily uh, bearing uh, the bearing damage because of the oil additives. Oil should not be mixed. Different types of the oil should not be mixed. It creates main problem and results in ammonia. So when this, many times people sell those magical additives, which says that improving the efficiency of the oil and system, it does not happen that way. You can see in the how the collision filters are getting choked, and you need to replace it. This is another additive being added, and you can see how they becomes a thick film, and it gets choked. So these products mixers get affects the is you can see here in the video how that oil is being gets sludged into it, and now it is being drained from the refrigeration plant. So this video clearly shows what happens is when you mix different oils, oil additives, and water is being mixed into the ammonia. We should avoid these things, and this is a very simple indication what is coming out here. It's from ammonia refrigeration plant. So what happens is that oil is not miscible in ammonia. It should be transported back to the compressor through the oil separator, or should be drained immediately. If it does not done that, then you always have a problem. This is if you see the arrow shown here shows various different drain points which are being provided into the refrigeration system. You can have an oil drain in the oil separator on the intermediate vessel, or into the high pressure receiver on the low pressure receiver side, and if it is a gravity fed system, it can be on the evaporator side. So when you are draining the oil, you should take proper precautions, because there is a possibility that ammonia may come out of the along with the oil. So the drain points must be provided at the bottom, and they should have a differential pressures. The So when you are using, you should use always the spring-loaded dead man's walls, easy. So which, if in case of any ammonia leak, it can be very easily closed. And the pressure in the system should be higher than the atmospheric pressure, so that you can take the oil out. Then oil, when the oil stops coming out of it, you should immediately let the wall get closed, and also close the wall behind your dead man's wall. These are the typical oil separators, oil rectifier systems, what we call, are provided particularly with the pump liquid overfeed system. And we should be providing such systems properly designed with a safety wall, so as to protect it from the any ammonia leakages. This photo shows some of the points showing the oil drain here. You can see those oil drain points here, and the such dead man's wall should be provided for the draining oil. You can see each dead man wall is provided with a stop wall. So normally the stop wall is closed, and when you want to drain, you open the stop wall, then you operate the dead man wall. And when you close the dead man wall, then close the stop wall, open dead man wall once again, so that anything accumulated between the wall and the dead man wall can be drained out. Now, next part, which is the part of the projection, is the rust, dust, and sludges which are being formed into the refrigeration system. So all refrigeration systems actually theoretically should not have any foreign metals like dust, great rust, or the impure oil, wax, sludges, etc. However, these systems always come into the system. They immediately damage your solenoid valves, control valves, and they chokes your filters. And when there is air and water in the system, rust formation starts inside pressure vessel pipes. As I told you, it is because most of our equipments are made with the steel. So when there is a water and air inside, it is definitely going to start the rusting. And during the installation process or maintenance process, welding bar also enters into the system. This welding bar gets into the system and then it chokes mostly the filters of the solenoid valves. Another important thing is that when you're installing the plant or when the things are being done, your pipes must be properly cleaned. When pipes are not cleaned properly, there is always this rust and the moisture which gets accumulated into it. That also helps to start more rusting inside the pipes, and that remains if it is not properly cleaned. Secondly, as I told you, the pressure vessels must be tested with the dry nitrogen, and it should, if you are testing it hydro testing actually, which is not allowed, it should be properly cleaned and it should be properly dried out. And then systems and SOPs has to be there in your plant to avoid any rust dust formation in the system. Please refer to ammonia installation and maintenance guidebook by Association of MR. See what happens is when the dust rust comes into the ammonia, it starts choking your walls. Walls get corroded, then walls you can see your wall sheets are getting damaged, covered with the rust, and the welding and then wall does not pass. A wall starts passing or wall does not hold. That's a typical complaint we find. It is because of this rust and dust. These are some of the photographs from the actual site. You can find here how much rust and dust is there into it. It means that when this plant was erected, it was not properly cleaned. There is a water in the ammonia system where they are not removing it continuously. This simply starts damaging your walls, your control walls, and this rust and dust always affects your total system performance, your performance of the controls. Controls get choked, controls get blocked, and it does not operate. You can see here how much rust is there in a small 15 filter. Or here it is very particular example. You can see the pilot valve, the port is getting choked because of the rust or the wax inside the system. Then this valve will not operate because if you see the port itself is choked. Then there are always such foreign particles you find coming inside the filter. Filters then get choked. Rustings are always then because of the water, there will be rusting inside the valves controls. Remember our all valves controls normally we use are steel valves. So there is a possibility when the ammonia with water comes into the contact, rusting formation is always there. Option is that to go for a stainless steel valves. Same thing happens with your screw compressor. The rust gets accumulated on your screws and then it damages your compressor body and compressor rotors. Compressor filters also choked, and you can see here this all filter is completely choked. So now you have to replace the filter, and when the filter is choked, your suction there will be a drop in the suction pressure. So your compressor will be operating at much lower capacity or will not get proper suction. So it will affect your performance of the system also. This is another example you see here. This level gauge is completely filled with the rust. The sludge is there in the level gauge, so you cannot see ammonia liquid. It means that the pressure vessel where this level gauge was installed is full with the rust and the sludge. You can see here you cannot see any ammonia liquid. All the black part is there. So this is what happens when you have sludge in the system. It main thing happens with this water and this sludge comes in is damages your safety walls. Your safety walls seats get damaged. So either safety wall leaks or it does not open when there is a higher pressure higher than your rating. And unless you are calibrating your safety valves, because safety valve is not a daily operating device, you don't know what is happening inside. And when that is required that safety valve needs to be operated, your safety valve will not operate. You need to calibrate your repair and calibrate your safety valves every year. So you can see in refrigerant systems, there is only refrigerant should be circulating the system and nothing others. All other materials are what we call as the impurities or the third party elements which are not required refrigeration. Secondly, ammonia has got very high affinity to the water. So when it comes with the contact, it absorbs the water. And as the ammonia temperature is low, we have a more absorption capacity of the water. Third, oil is not miscible in ammonia refrigeration. So it gets carried over along with the ammonia and it gets accumulated in every part of the refrigeration system. Oil being heavier than ammonia, it gets at the bottom of the evaporators, receivers, or your intermediate vessels, LP vessels. It gets accumulated there and starts affecting the refrigeration performance. Water in ammonia refrigeration system affects the refrigeration efficiency because we have to operate at lower suction pressure to get the desired temperature, or we need more refrigeration capacity. It uh, accelerates the corrosion inside the system because our walls, controls, pressure vessels are mostly are made from the steel. Then it immediately affects the oil in the compressor. Oil life deteriorates, bearing life deteriorates, compressor spare part consumption increases, oil consumption increases, and it chokes with, it forms the sludges, it chokes the filter, it chokes the controlling devices, it chokes the level controller operations, and overall the system performance deteriorates. When oil gets accumulated in the evaporator, you don't get the desired temperature effects, and overall it affects the complete system. Rust, as I said, rust affects everything. It affects your compressors. It damages your pistons or your screw compressors rotors. It damages your solenoid valves. It damages your expansion devices, and overall whole system gets affected. Your desired temperature you don't get the desired COP. You spend more money on running the plant. You spend more on your maintenance of the plant. So having a correct ammonia refrigeration system means your ammonia has to be pure, but at the same time, you must use systems which will remove water regularly from your ammonia plant. You should use correct and good quality ammonia oil separators so that oil does not get carried over into the evaporator side and oil is returned back to the system or oil is drained properly. And if there is the, and should always take care that when you are evacuating the, when you are opening the certain ammonia plants for servicing purpose, you are evacuating it properly before putting it back into the system, so the lesser water or the air enters into the system. If you have and when there is air coming in system, always remember it will bring in the water in the system, and that water has to be removed, separated from ammonia, and it has to be removed. Thus, to have a better performance of refrigeration system, your system must be free of water and rust, and oil should remain only into the compressor or the compressor oil coolers and oil separators. It should not go beyond that. That's all. And then what I want to do is thanks very specially to Dr. Ashish Kadam and Mr. Dhananjay Deshpande, who helped me a lot, shared a lot of information and their slides in making this presentation. And again, I thank Association of Ammonia Refrigeration for giving me opportunity to make this presentation. Thank you, everyone. Thank you very much, Harish.
Yeah, thank you, Mr. Anand Joshi, for this valuable presentation. I hope it is useful to everyone to learn this. So we have a few questions. So we will take up that. And others also, if you have any questions, you can put it over there. So first question is from Mr. Shivcharan Patel. How to identify water in our system?
Well, very basic thing you can do is that you check your suction pressure and actual temperature you have received. That is one way of identifying that if your suction temperature and the rated temperature you are able to achieve, it means the water contamination is less. Secondly, the ammonia sampler kits are available. You can connect it into your low pressure side, take a ammonia sample into it, and then it can help you to find out the exact water content into the system.
Okay. So other question is how to maintain the oil temperature after proceeding for drain.
Oil temperature when you are draining, it will come to your ambient temperature. So when you are draining the oil, particularly when you are draining it from the low pressure side, it will be at the low temperature. So when you drain it out, you check the quality of the oil, whether you want to filter and reuse it, or you want to just throw it away, or just accumulate into drum and then dispose it off. You need to put it into the ambient temperature for certain time so that it comes to the ambient temperature, and at the same time, if there is any refrigerant content into it, it will evaporate.
Okay. Okay. This another question. Okay. Does the water enter the system just by moisture during installing the system or when leak occurs?
Water enters in multiple times and continuously in our system. One is that when there is a leak occurs, the air enters into the system, and along with the air, the moisture in the air enters into the system. Secondly, the ammonia which we put into the system, it contains the water. Third point is that when your systems are not properly evacuated, or you do the pneumatics testing instead of the nitrogen system, the air which is used for the testing also gets the bringing the water inside the system. So water is coming continuously into the plant.
Okay. So now another question, what is the acceptable oil carryover ppm in an ammonia refrigeration system?
That question has to be answered by the compressor, because it depends compressor. All the oil carryover occurs from the compressor. So
I'll,
that
I'll,
should be,
I'll answer that. Okay.
yeah.
So see, the oil carryover should be as minimum as possible, preferably zero. Okay, but since compressors are oil flooded, there is bound to be some oil carryover because it's not achievable, not possible to achieve zero. But normally the compressors, if we have a compressor and a good oil separator, the oil carryover is around 25 to 30 ppm if you have a coalescer elements. Okay. Now when coalescer elements are not present, you just have a vessel, then the oil carryover is very high. Okay, it can be 100 ppm, 200 ppm, 300 ppm also in some cases. So yeah, and when we particularly work in very stringent requirements are there, like if we are using a say a system for a petrochemical industry, they don't want any oil to go forward. So that time we go for a secondary oil separator as well, and then restrict it to 5 ppm. Okay, below 5 is really very difficult. So those are the limits. Like normally, if you have reciprocating compressors where the manufacturers don't give coalescer elements, then the oil carryover is very high. So there's one more question related to that about particular make of compressors. So yes, the oil carryover is very high if there are no coalescer elements, but with coalescing elements and proper oil separator, we can reduce this oil carryover.
We can say, Harish, that using a proper quality of the oil separators or replacing your existing oil separators has a very high, very less payback time, and very more and generates more efficiency of the system.
Yes, yes, because if oil goes and collects in the system somewhere, that hampers your efficiency. So you should obviously have a very good oil separator. The question, ammonia and oil analysis should be in place. What should be the interval of testing these?
Ammonia should be tested every 6 months for the particularly for the your water content into the ammonia. Whereas oil, you should keep on monitoring regularly, and the frequency has to be depend on your compressor and the oil separators of your compressors. As recent as Harish told, if your oil separators are not good, your oil carryover is going to be high, and also it will, and your discharge temperature or the condensing temperature, condenser performance also affects the oil temperature. So that frequency, as it is mentioned, if you see the AR installation and maintenance handbook, it says that oil must be monitored, oil quality must be tested every month.
Another question, can we check the ammonia for water before we charge the system?
We can check the ammonia before the water provide using the proper testing system, where we can expand the ammonia into the vessel and take it into the ammonia sampling kit, and then find out the moisture content into it.
Another thing is like we go for a good quality ammonia also with of high purity. So then it won't have
We
water.
can ask for the certificate of the ammonia, purity certificate of the ammonia.
Is it possible to use screw compressor oil in reciprocating compressor?
Compressors normally use synthetic oils, so you can use it in the reciprocating compressor, provided you have totally evacuated or removed your existing oil completely, clean the compressor, and then you charge. If the both systems are same, then you can definitely you have to charge the same oil into the both system. Independently, synthetic oils are available for piston compressor also, and you can use them.
Another question, can we add filter dryers in the liquid line?
There are no filter dryers for ammonia.
Okay, so that's all. Then there are questions regarding the presentation file. So we'll be uploading the presentation on AR website. The members can download it from there. Those who are not members, request you all to become members to avail this facility. We want more and more people to become members. So Anand, that's all the questions. I think
Yeah,
we'll conclude. Let me share my
yeah,
screen.
yeah, please.
Okay, so we have a next webinar coming up on 15th of July, sustainability with ammonia refrigeration. So sustainability is a lot of things are being talked about it globally. So we are going to learn from another expert, Mr. Sudhir Kumar, who's director at Frick India Limited on this subject. He's going to share his experience on this matter. So the link and the QR code both are given over here. So you can please take this. So I thank participants for joining. Our expert speaker, Mr. Anand Joshi, the webinar partners, Manik, Frick India, Darren Brown, and Neptune Refrigeration. So thank you all for joining this, and hope to see you next week. Yeah, thank you all. So with that,
Thank you all for joining us. Thank you.